Welcome to my YouTube channel. So here today we are going to be answering questions involving banked road. So what is a banked road? So under this video we are going to be solving these three questions. So this one, and this one. So now, how do we answer such problems? So firstly, we are going to be looking at it like this. So a banked road is a road that looks like this. So we can have an angle like that. Then we have a road like that. So this is just an example. We have a road like that. So this is the road like that. Now the car is here, so it is trying to move in this direction. Now at all points, the road is banked. It is not just at that point. We have at all points, the road is banked like that. So that is basically what a banked road. So it's something that looks like this. So it will be moving like that. So as a result of the position where the car is, so here there is an angle theta. So just imagine at all points, the road is banked like that. So now, with that said, what we are going to have is, if the angle theta is here, automatically, if we do this, the angle will also be here. So now, as you see, the force that points upwards is the normal force. Then the normal force, if you see where the angle is, shall be distributed into its components. Let's draw it so that we are able to see now. We have this, then we have the normal force like this. So this normal force, so that's the normal force. Then we have said that the angle is here, the angle theta. So if you extend this line, you are going to meet the weight of the object, our mg, like that. Then, since the angle is here and it is in contact with Fn, whatever side is attached to an angle, it shall carry the cosine of theta like that. Then down here, it shall be, if this is cos, this will be sine like that, sine of theta like that. So this is how we do it. So this is how the forces are oriented. So now, likewise, if you are required to say the summation of forces in the y, summation of forces in the y is equal to 0, like that. One thing that you need to know is that the car is not like leaving contact. So the road is banked. That means to say at all points, that is how it is. So even if it was to come there, it is still the same situation. The car will be still here. So this contact is maintained. So that's why we say that the summation of forces in the y is equal to 0. Then we are going to have the F. So now, as you can see, the opposite sides is the mg, and this. So you can say the summation of forces in the x is equal to 0. So Fn minus, so Fn cosine of theta minus mg is equal to 0. So this, when it comes here, it will be Fn cosine of theta should be equal to mg like that. So this is the first equation that can be created. Then if you look at the diagram, if we have a banked road like this, we have the road, it's like that. Then this road is like that, it's like that. So now this road experiences a force, or rather the car experiences a force that is pushing it towards the center. And this one, as you can see, is mg Fn sine of theta. In this case, we are dealing with Fn. So we say Fn sine of theta points to the center. So whatever points to the center produces the centripetal force. So we are going to say summation of forces in the x. In the x, since it is pointing in the center, then there is certainly the acceleration due to friction. So that's why we say MSC to represent the acceleration of friction. So we are going to say, what force do we have? So it will be Fn sine of theta is the one that produces the centripetal force, should be equal to MSC. So one of the advantages of banking a road is you want a road that can be able to curve, or rather you want the car to curve without relying on friction. So you are not relying on friction as other problems which we have solved. So if you look at that, so this is basically the knowledge that you need, and you know that the centripetal acceleration is equal to v squared over r. V squared over r. So you can say, if you want, mv squared over r. So this is our Fn sine of theta. But that was just the introduction. Let's now look at this question. Let's say we have a question which says that a car has to move on a curved and banked highway. Show that the maximum speed allowed for the car to negotiate the curve without assistance from the force of friction is given by. So this is, we are required to show this. So what we are going to say is that, so we have a car, so we can even put the lamp like this. We have the angle theta, we have the car. So you create the diagram first, then you are going to say the normal force. The angle will be here, theta. Then distributing the normal force into its components, this one will be Fn cosine of theta. This other one will be Fn sine of our angle theta, like that. So with that, we are going to say summation of forces in the y should be equal to 0, and say which forces. So if you extend this, you are going to have your mg like that. So this will give us our Fn. So the one that is up is Fn cosine of theta minus the opposite one is the mg should be equal to 0. So when this mg goes this side, it will be Fn cosine of theta should be equal to mg. Then the other one will be summation of forces in the x is equal to 0 as well. So which one? It is the Fn sine of theta that provides the centripetal force, which will be Fn sine of our angle theta should be equal to, we have mac like that. Now we want to show the velocity, so that means to say where you see centripetal acceleration, you put the velocity. So you are going to say mv squared like that, Fn sine of our angle theta like that. So we have these two equations. Now remember, we have the tan here, so we can do this in two ways. We can even divide. So divide, let's say this is our equation 2, this is our equation 1. Divide equation 2 divided by equation 1. So why divide? Always the one with sign has to be on top. So we are going to say Fn sine of our theta should be equal to mv squared like that, over dividing over our Fn cosine of theta over our mg like that. So there are many ways. If you want, you can make Fn the subject of the formula. So this and this goes, then we are going to have this and this goes. So you are going to remain with sine theta over the cosine of theta is equivalent to sine over cos is always tan of theta should be equal to v squared over our g like that. Where did our r go? mv squared over r. This one, mv squared, centripetal acceleration is mv squared over r. So that means over the r, let me just do this. So it will be, this is over r. So we are dividing the Fn cosine of theta. Then this one, we have r for this other equation on top. So whatever is here, we'll just join whatever it will find here, since we are dividing. So it will be mg like that. So this and this cancels, this and this cancels. Then we are going to remain with our sine over cos. Then we have v squared over our rg like that. So with this, we want to make v the subject of the formula, so we cross multiply. So it will be v squared is equal to this times this, v squared times 1 is v squared. then this times this, it will be rg tangent of theta, which will give us our roots. So our v should be equal to the square root of our rg tangent of theta. So this is what they want, so we can say hence shown. Let's do it one more time. So a car goes round a cave of 48 meters if the road is banked at an angle of 15 degrees with the horizontal. At what maximum speed in kilometers per hour may the car travel if there is no tendency to skid even on a very slippery pavement? So same approach, you're going to draw this. Your theta is here, you have the car there, the one that is up is the Fn. Fn can be distributed into its components to give you Fn cosine of theta on top. Then here it will be Fn sine of our theta, like that. So with this done, we are going to have so remember it's like that. So we have the summation of forces in the y should be equal to 0. So we have, which forces are those? We have the Fn, opposite is the mg. So you have the Fn cosine of theta minus mg is equal to 0. So our Fn cosine of theta should be equal to mg, like that. Likewise, our summation of forces in the x is equal to this one is the one that is providing the centripetal acceleration, so we'll be able to say MSC, like that. So this gives us our summation of forces in the x. Which ones are those? It is this one. So we can say Fn sine of theta should be equal to MAC, like that. So we want the velocity, so automatically this has to go. So we will have Fn sine of theta should be equal to m. Centripetal acceleration is v squared over r, like that. So we are going to get, so dividing these two, we are going to have our Fn cosine of our theta should be equal to mg. Then our, so dividing, if we want, we cannot divide, we can just make one the subject of a formula, but let's just divide to make things easier. So dividing, we have always the one with sine is the one you put on top. So we are going to have Fn sine of theta should be equal to mv squared over r. Then divide this by Fn cosine of theta. Then we have, this is having mg, so you put the mg down here, so it joins the r there. So what we are going to have is this and this will go, then this and this will go, to give us sine over cos is the tangent of theta should be equal to v squared over r. We cross multiply rg. We cross multiply, it will be tan of theta. Rg should be equal to v squared. We find the root, then we can be able to say v should be equal to the square root of our tan of theta, rg. So v should be equal to the square root of our tan of, what is our angle? Our angle is 15 degrees, if I'm not mistaken, times the radius, which is 48 meters. So we are going to say times 48 meters times the gravity, which is our 9.8. So pressing all this together, this gives us v is equal to, we are going to have our root of our tan of 15 degrees times 48 times 9.8. This gives us a value that is equivalent to 126. So 0.04. The square root of 126.04 gives us a value that is equivalent to 11.23 meters per second, but they want it to be in kilometers per hour. So you're going to convert using the changing conversion. You're going to put your 11.23 meters per 1 second. 1 second. Then you're going to say times. The second is up down here, so you need to find the second up there. So second, then down you're going to put the minute. In 1 second there is exactly 60 seconds, or in 1 minute there's exactly 60 seconds. That means this second and this second goes. Then you are going to convert your hour, your minutes to hour. So it will be, you make your minute there, you put the hour down here, since the minute is down here. So this gives you, you know that there are 60 minutes in 1 hour. Then times. Times, we are going to have our value. We are going to have our value, which will be equal to, times our value, which will be equal to what value? So we have converted to hour. Then for minute, we are going to do the same. Or meter, we know that the meter is up there, so it should be down here. So there are 1000 meters in 1 kilometer. So that this and this goes, then we are going to multiply 11.23 times 60 times 60 times 1 kilometer over 1000. This gives us our 11.23 times 60 times 60 divided by 1000. This gives us a value that will be equivalent to 40.428 kilometers per hour. Our last question for this one is, what is it saying? It's saying they have given us the speed and they want us to be able to find the designated speed for a banked curve. So we have banked curve of radius 50 meters is 13.4. At what angle should the curve be banked? So the approach is the same. So we are going to begin. Now we are even conversant. We have, it's going this side, so the angle is here. We have Fn cosine of theta. We have Fn sine of theta. Then this gives us the mg there. So we are just going to do the same thing. So this is going to be our mg. Summation of forces in the y is equal to 0. So we have the Fn cosine of theta minus the mg should be equal to 0. So this goes this side. Our Fn cosine of theta should be equal to mg. So then our Fn sine of theta, that's the summation of forces in the x, which is producing the centripetal force, should be equal to MAC. In this case, they have given us the speed, so we can be able to say Fn sine of theta should be equal to mv squared over r, which gives us this value. Then we divide equation number 2 divided by equation number 1. This gives us, just in case, if you want, you can just say, you can make Fn the subject of a formula, this the subject of a formula, then replace whichever one, it still works. So in this case, we have our Fn sine of theta should be equal to mv squared over r. Then this one will divide. We have the Fn cosine of theta. Then we have our mg like that. This. So we have this cancels. Sine over cos will give us the tan of theta should be equal to v squared over gr or rg. So our tan of theta should be equal to, what is our v? Our v is 13.4. So we say for 13.4 squared over our rg 9.8 times our radius, which is equivalent to 50. So we say 50 tan of theta should be equal to, we have our 13.4 squared. This gives us a value of 179.56 over our 9.8 times 50 gives us 490. So we divide, our tan of theta will be equal to, in fact we can just press like this. So let the tan go this side. If it goes this side, it becomes tan inverse. So theta is equal to tan inverse of our 179.56 over the 490, like this. So the theta should be equal to our tan inverse of our 179.56 divided by 490, like this. So the value that we are going to get is a 20.13 degrees. So that's that on banked road without friction. In other videos, we are going to look at different concepts.